Alright, so this is the last one for the week. Thanks for making it this far. I've thrown a bunch of stuff at you, but hopefully you're finding all of it fun and kind of interesting. This one we're going to play with something called jit.matrixset. It's a little finicky, but it's really powerful and fun once you get used to it. I find it more useful for like installations, maybe than performance, but we'll see what you can get out of it. But yeah, I'm just going to dive right into it. So it's just type it out like this, and you can see what it says here. It says a set of matrices for storage and resequencing. And we need to give it 5 arguments, and I'll just type them out and say what they are once we So right away, this stuff should look familiar to you. In fact, the only thing that's different, this is literally what we've been working with, chip matrix, 4 planes, char data, 640 by 480. I guess I can't do it like that. With this matrix set object, we have one more argument. I put a 30 here, right at the beginning. And what that's saying is, let's see, if I just planes, data, xdim, ydim, you could think of that argument right here as the z-dim, the z dimension, because we're kind of just making a 3D matrix here. Not only do we have 640 by 480 pixels, but we're saying how many frames do we have. So it might be easier to think of it as number of frames that we're storing. And the way we do that is with 2 different arguments, or there's one argument. There's the index, and it says matrix to be written to the index number. And then we have another message called output matrix, which I'll get to in a second. But I'm going to set up my camera. Open Q Metro 33 toggle. And jit.p window. We are in business. And I'm also going to send it to here. Now I'll make a jit.p window here. I'll make this one a little bigger. And we don't see anything right now. It's because this is storing things, and we have to tell it to store an incoming frame using the index message, and then we have to tell it to output that stored matrix using the output matrix message. Yeah, there's that. I think you get the idea there, hopefully. So if I got rid of the $11 for a second and just said index 0, and we're constantly sending frames and matrices through that pipeline 30 times a second. And if I just click index 0 while it's receiving these matrices, and then I say output matrix 0, we get 1 frame. And what's literally happening is I'm telling it, store that incoming frame when I send this message at index 0. And it'll store that for me at 640 by 480, just like a matrix. And then I can recall that matrix by giving it the index value we stored it at with this message output matrix. So I'm going to, I could do it like this. I could have a counter, and I could give it a 29. And I'm just going to move my head around and boom, 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 boom. I'll also help you like see what's coming out of here. Boom, 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 boom. I'm just storing all these frames, And now I have all the, every time I sent that message there with the counter to the index, it stored all those there. And you can see it's kind of choppy because I was like literally just clicking bang, 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 so it's not grabbing each of those frames. If I started to hook up the Q metro that's driving our thing here to the counter, what's interesting here is it's actually just continuously overriding all the different index messages with this. And I want to just store 1 second of information. I want to build something where it counts 30 indexes and then it closes it, and then I can play back with it in a second. That sounded terrible when I said it all like that, but I'm going to build this out and you'll see what I'm talking about. Essentially what I want to happen is I want to be able to turn a toggle or send a bang and say start counting to 30, and once I get 30 frames that are stored in here, then I'll close that gate that I'm going to use so that I just have those 30 stored right there. And I could click on it again if I wanted to get a new sample of 1 second of 30 frames. So I'm going to do that. Let me think about this. I definitely want a gate because I need to close when these bangs are coming in. You know what I'm saying? Like a gate basically takes a 0 or a 1 message in its first inlet, and if I open the gate, it lets information through, and if I close the gate, it blocks. It closes the gate. There's no information that can pass through. And I want that gate to close whenever we get to the top of the counter. So I could do select 29. Select just sends out a bang whenever it receives a value as an argument. So I could hook that up here. And I don't want to send a bang to this, because if I send a bang to the toggle, it'll alternate back and forth, on, off. I just want to always make sure that it's off. So I'm going to do something called trigger. And trigger is an amazing Max object that I love. I use it all the time. Basically, whenever it receives a bang, I can send out a multitude of different messages. So I can say trigger 0, and it will literally send out a 0 when it gets a bang. And I can hook that up here. And rather, if I ever send a 0 to a toggle, I'll always just turn it off. So let's clean this up. I'm going to zoom out a tiny bit. Let's get nice and organized here. We got our output matrix. That's good to go. Hide this a little over here. Move this down. Oh, there we go. And so I got my gate here. And we need, the gate has the bangs coming out of it. And let's see if I open that up. Where are we at on this? It looks like that works. So just to walk you through what's happening here, I have my bangs coming out of this Q metro into this gate object. It's blocking any of those bangs coming through unless I open it with this toggle object. And once it starts coming through, counter, I gave it this argument of 29. And what it means is when it gets to 29, it'll loop back to 0. So every bang it gets, it's just counting until it gets to 29, it goes back to 0. And I'm sending that to the index. And that index is in charge of saying whatever frame I receive after I get that index value, then I'm going to store that frame there. However, at the same time, we're sending that number out of the counter through the select object. And the select is just checking all of those numbers and not doing anything until it gets a 29. And when it gets a 29, it triggers a message of 0 back to the gate so that it closes it once we're at here. So I'm gonna do something where I just look to the left. I can do it even a little faster. So over 1 second, I just looked from left to right. Now I bet, start at 0. And now I have essentially all these frames And it looks like I made a mistake there. Let's change this to 30. I thought it was in, I think it's index 0, but there's some kind of thing going on. Does this still work? Yeah, that seems to work better. Okay, I'll try that again. I can do a little better than that. I mean, you get the idea. Now I just have 1 second of frame information sampled in here that I can play back on my own. And that's really fun because, I mean, right away, I can just do random 30. Oop, not that one. I can take that same Q metro. And now I'm just playing back any one of these frames randomly. And because they're close enough to each other, you can see the relationship to each other. And this one really rewards movement. If I were just standing still or just talking to you, it wouldn't be nearly as interesting. I could also bring that counter object back over here and just play that on a loop. I could also, what else could I do? I could do the drunk object. Drunk is like random, except if I say drunk 33, I'll get, every random number I get will be within 3 of the previous value range. So now I get something that's a little like, and like, I'm going to show you one last cool thing that maybe will confuse you a little bit, because I know we tried doing some of this MSP stuff. I'm going to get rid of this just to clean it up. So this is in charge of me just getting all my stuff. This is in charge of outputting the matrix. I'm going to make an object called EasyADC. This is the opposite of what I showed you in class, audio input and on and off button. If I hit enter, it turns into that thing with the tilde here. So this is an MSP object. And it shows you a little microphone. And I can actually go to options, audio status here. I'll just hover over that for a second so you can find it. And it'll show me what my input device and what my output device are on my computer. And right now it's just my built-in microphone. Fantastic, groovy. When I lock the patch and I click on this, and that turns my audio on, so to speak, in MSP land. It's kind of the equivalent of turning our Q Metro 33 to drive everything. Just for MSP objects to work, you need to make sure it's on. That's just the easiest way to turn it on and off. There are other ways, though. I think I can do, let's see, what would be a good signal? Gain? This one I need. Check, no. I need, I'm going to open up the help here just to see what, I just want to get the, oh, here we go. So this is the meter reference. So maybe I can just turn, okay, object, meter, visual peak level indicator. And yeah, that's working. You can hear me talking. You can see it's basically just taking the amplitude of whatever the incoming microphone is. And this is channel 1, channel 2. I guess I only need 1 channel. I think, you know, it's a microphone, so this kind of stereo wouldn't matter as much. And I want to turn this, if I make that number object, is this actually giving me like a yes. So, whoa. Hey, yeah, you can see it's kind of just turning that into a signal number. So I can do that snapshot. And I'm going to do that trick I kind of showed you. I'm going to say send draw, because I don't want to grab something all the way over there. I'm going to hook up my Q metro to that. And I'll say receive draw. And anywhere I have a send message with a name, anywhere I make a receive with the same name, it'll receive those bangs. So you can see it's receiving those bangs from our Q metro object over here. The nice thing is I'm not like dragging all the way across the patch to do that. It keeps things a little cleaner for me. And snapshot will turn a signal this is the number tilde object. It'll turn a signal into a number we can hook up to one of these things, like the output matrix. You see, like if I have this MSP thing, I can't hook it up to that. I have to convert it into an actual number and not an audio signal. And if I make a float, I'll have to, and the snapshot needs to receive a bang to output its current number. Check, check. Oh wait, that's not working. Why is that not working? Receive, draw. Sorry, while I debug this really quick. I'm kind of making, I didn't plan on doing this part for this tutorial, so I'm kind of making this up as I go. Do I need to, if I just multiply that signal? Is that the issue, or is it just no, check, check, check? Okay, so maybe this idea isn't going to work. I was going to hook up the volume indicator to our matrix to drive that. I really want to figure this out, but I don't want to waste your time just sitting here watching me do this. Nope, not that. Oh, I think maybe I just can't. Yeah, I think I know what it is. Check. Yep. My bad. I can't just pass information through this for some reason. I don't know why. I thought it would work like a float does, but apparently that's not the case. So here we go. And you can see, I'm just going, let's see, I just scale that from 0.0 to 1.0 to 0 to 30. That going to work the way I think it's working? Check. Check. I'm actually going to do something called ZMap. Scale is the same as map, but if I have any values that go over 1 or under 0, it'll continue scaling the same way. But ZMap will block it and say I'll only go to 30 and I'll only go to 0. Check. Check. This also doesn't seem to be working that well. Let's see. Can I just, I'll go back to the idea of multiplying the signal. I think it's just kind of weak. So I'm going to boost the signal by just multiplying it by 3. Check. 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 This is really going off the rails. All right. Ignore all that. I'm sorry. I'll figure out how to do that for another class. But you could do the whole thing we tried before, which is like a cycle wave, which is a sine wave. I'll do 0.3, and then I do a snapshot. Then I say receive, draw. That's working great. It's -1 to 1, so I'll scale that. So we have this oscillation between 0 to 30. It's kind of nice because it actually fits me turning my head. So it kind of slows down when it gets into position, and it speeds up as it moves through. And I can change the frequency of the sine wave to be faster. And eventually it gets so fast that like it just kind of gibberish, and it's actually like out of phase with our screen refresh rate. So I can also do it really slow. Although then you start to see the frame blending here a little. Or not the frame blending, but the lack of frame blending, where it's just like the frame rate of how it grabbed those different frames. Back and forth. And this is me saying, no, 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 no. Like, I could also make it say, yes, 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 no, 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 no. Yes, 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 yes. No, 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 no. Okay, that's probably that's not even a yes or a no anymore. It's just a lot of different things. So yeah, go ahead and play with the jit.matrixset object. It's really fun to do this. One word of caution: you can do more frames than 30, but it's actually storing all these frames in your computer memory. Uh, and if you give it too many frames, it might actually cause Macs to crash. I wouldn't go higher than 120, and even then you might have a little trouble. Um, and if you want to keep in mind also the resolution of your image. If you're asking it to store 30 frames of 1920 by 1080, that's a whole lot more data than 640 by 480. So you might be able to store 240 frames if you downsample it to like 320, 240, or 160, 120. So these kind of have a relationship with each other. You could also do a grayscale image with the JIT RGB to Luma in one plane, and that's a quarter of the information that you'd be storing. So all of this, it works in tandem together for how much storage you're asking your computer memory to keep. So you can play with that to see if you wanted to get like really long storage of different frames and whatnot. So have fun with that.